Mesra Alumni Association North America, known as BITMAA-NA. A warm welcome to all to the BITMAA-NA faculty webinar. Today is one of the series of BITMAA-NA's faculty webinars that we started earlier this year. Today our speaker is a BIT Mesra luminary, Rohit Prasad, a native of Ranchi and a 1997 graduate in electronics and communication. Rohit did his MS from Illinois Institute of Technology in 1999 and attended the executive program at MIT School of Management. Currently, Rohit at Amazon is the vice president and head scientist of Alexa, artificial intelligence, where Rohit directs the groundbreaking artificial intelligence R&D work for Amazon Alexa and has made Alexa a household name worldwide. For BITMAA-NA, it's a great honor that Rohit is a member of the BITMAA-NA board, and for this we are very grateful to Rohit. Today, Rohit's presentation will be for about an hour. Then we will open up for question and answer session. In order to ensure good session and provide maximum value to all, we request that you all be on mute and use the Zoom or YouTube live comment section to share your questions. Kindly share your name, department, badge, etc. when you ask your question. We will try to take maximum questions as the time permits. We will stop at 11:30 a.m. Eastern Standard Time or 10 p.m. Indian Standard Time. Without further ado, here is Rohit Prasad.
Thank you so much, Surinder sir, and it's a pleasure to be here. Sharat was nice enough to share the background for BIT, and so I know these are very difficult times with COVID that I wish we could have done this live in BIT, but this is the best we can do, and with the virtual communications infrastructure nowadays, it's not very alien to do presentations like this on Zoom or other channels. So thank you, and I'm very excited. So I'll start sharing my screen with the presentation. If you have a question, I'm happy to take it anytime, but looks like it would, given the large audience, it may work best if we are taking it at the end. Everything good? Can we get started? Can you see my screen?
Yes, we can. Yeah.
Yes, we can.
So, I thought the best way to say given where we are, is that it is a golden age of artificial intelligence. And if you look at what people are saying about AI, this is not moving. Give me a second. Yep. Can you see the screen?
Yes.
Okay. So if you look at this Forbes call out that came in 2019, it says a survey of more than 1,000 executives released by Relax confirms this is the golden age of AI. And that's because if you look at adoption of AI, it's increasing in huge bounds. And that's exactly what we want to see when a technology is making a difference in daily lives. And but before we get there, I wanted to start with a common definition of artificial intelligence, because there's a lot of misconception of what AI is, and everyone has a very different view. So if you look at that, AI is essentially intelligence that is demonstrated by machines. And there's a lot of debate on what that intelligence means. Is it human-like intelligence, or something that is very machine-like? And I've subscribed to the fact that human-like attributes are critical, like how we learn, how we acquire knowledge, and how we take those knowledge and apply to certain skills or tasks. Machines have always lagged in that aspect of knowledge acquisition automatically, as we do as humans, with a lot of self-supervision. We learn on our own. And but at the same time, given what really happens, it's important that intelligence be such that machine-like efficiency of intelligence is also critical. So when I think of machines having intelligence, it's a combination of what humans are great at and what machines are great at. So if you look at where we are with state of the AI, when we talk about artificial intelligence in our daily lives, applications for AI are coming everywhere. Self-driving car is an instantiation of artificial intelligence with a lot of sensors in the car. Finance industry is adopting a lot of AI in decisions on trading, portfolio management, and so forth. Healthcare, which is always the most critical industry and often the most difficult to inject technology of such kind, is also adopting AI. And lastly, AI assistants in the form of Apple Siri, Google Now, or Google Assistant Now, and Amazon Echo or Alexa, the assistant behind the Echo family of devices, are also getting hugely popular, and billions of users worldwide are using these. So this is very encouraging times for AI applications. What's also happening is if you look at how people, like a lot of your students, on where do you go and use AI if in your workflow, or if you're a developer in a company, how do you use AI? And or even if you're not an expert programmer or any of that, how does AI help you with your business decisions in whatever enterprise you are in? And for that, what's really happening is we are getting into more full stack, as in an end-to-end solutions, and also different, where you can integrate in each of the layers of AI capabilities as a developer. So it's very, very exciting times. So if you're a student and you wanted to get your hands into artificial intelligence, and then there is a bunch of libraries where deep learning specifically, which I'll talk about later, where these are open source frameworks that you can integrate or play with and then integrate it in your project by simply either going to the GitHub, or if you were looking at some commercial offerings, then you can go to AWS or Google Cloud offerings or Microsoft Azure and try these deep learning libraries for your own project. It's very simple. Like anyone, even my teenagers are able to now download these libraries or play with them at their own will for their tasks. But these libraries can be still, like, they're great for research, but if you were really trying to productize it, it requires a lot of workflow, from getting to data to models for machine learning. And for that, you have offerings which are very workflow oriented on like Amazon SageMaker makes it very easy for you to take your data in your enterprise or your university and put it such that you can actually use it in your application. So that is another level of abstraction in this full stack thinking. And you can then optimize it for your own task. Let's say you were looking at classifying images, then you can use Amazon SageMaker to build a workflow for classifying images into different form of business decisions or your class project or whatever you are interested in making some predictions on. Then you have more custom AI services, and I mean custom in the terms of the task they do. So let's say you wanted to use an engine where you had a lot of text, and if you're building an application for people who are blind or who can't read well, then you can inject for that kind of application. You can use like a text-to-speech capability like Amazon Poly, which converts text into audio. Or the other way, like you can transcribe automatically conversations that if someone can't hear, then they can read the text, or other applications with Amazon Transcribe, which is an AWS offering. Or you can build your own enterprise chatbot. Let's say you wanted for a student group, wanted a chatbot that answers common questions about the campus and what's going on. Someone can go and integrate with Amazon Lex and build that chatbot that lets you get some answers with natural language. And similar companies like Google and others have similar offerings, but it's exciting that you can integrate there itself. What's also happening, where a lot of this AI and machine learning behind it was powered by graphical processing unit advances. But even there, we are now having custom chips to make what we call inferences or predictions fast, and that's happening. And also on the cloud side, the training infrastructure is getting much more competent, that in terms of computational efficiency, you can train that very massive models with huge billions of parameters much more efficiently. But it's gravitating to more purpose-built chips as well, which is great for the AI researchers like us, because we can get performance that was very hard to get previously. So I talked about artificial intelligence, but then I also mentioned a lot about what's I kept calling machine learning. So machine learning, the way to think about it is that when old school AI was being done, a lot of it was with explicit programming with if this condition happens, then do this. So what you can think of it as very rule-based AI, or and with some symbolic logic and so forth. But those don't scale because rules start conflicting. You have to enumerate all of them, and you have to always maintain them, which is super hard. So what happened was with machine learning, definitely I would say in the 80s is when this took off, was where we started getting to gravitating towards more model-based techniques, which are probabilistic models that are trained on example data, where let's take speech recognition for the example, where the task is you go from audio to text. So if you had a lot of text data for conversations or broadcast audio, just that there's the audio snippet and here's the text for it that someone has transcribed, nothing else. Then you could build a model that, given a new sample of audio, is able to produce a prediction of text. So that you can think of it as the recognition layer, which is, or the prediction layer, which says there's a decoder that takes the input and output comes out as answers. If it was speech, the answer we were seeking for speech recognition was text. If it was image, let's say you were classifying images of animals, then there are a bunch of images and you output which animal type it is. And all that happens because you have given a lot of input data with ground truth, which using a training algorithm is now building a model, and that model is used in runtime on unseen data to produce answers. So that, in a simplistic way, is what is the data-driven machine learning. There are many different modeling architectures and many different learning techniques. So there's a whole class of classifiers that can do this for you. But the one that has become very popular is essentially what we call deep learning, and specifically deep neural networks. So if you look at this bubble of concentric bubbles, then if AI is the massive field, machine learning is a subset of AI, where the school of thought is that you should be building probabilistic models rather than explicitly programming the machine to make predictions on a new task, essentially on new data. And deep learning is a subset of machine learning, where you're using more bio-inspired, like how brains work with neurons and activation of these neurons. Very similar thinking here, encapsulated in a large parametric probabilistic model, where you can think of that there are two layers at the outer edges, which is the input layer and the output layer. The input layer, very much like, imagine if it was speech or image, that you have a bunch of input neurons, and then on the output is where you're getting the predictions or answers. In between, there are many neurons that are hidden, essentially, and there can be many layers. And what we do here is essentially, of course, have an activation function for each layer. But what we train is a bunch of weights that are optimized on large quantities of training data that I showed in the previous slide, to make these parameters be learned. You start, of course, with many different initialization. And once this model is trained using many different algorithms, but the most popular being backpropagation, is that you will generate a bunch of predictions or answers. So this is one of the most popular techniques, and I would say in the last 8 years has really taken off and made a lot of new tasks happen, which was thought to be quite impossible. Now, the underpinnings of neural networks was always there. It's not like the whole field was new, but the combination of massive computing power made it such that we could train these networks much faster and better. And then the field has come with many different topologies. You may have heard about transformer techniques and so forth that has made this be very, very powerful. And some success you see is already happening a lot with adoption of these technologies. But if you look at step back and say, okay, we talked about AI, we talked about machine learning, and we talked about deep learning. What does it all mean in terms of where AI is? So if you think about AI, especially the science aspects of it, you can think of it as being a stack, where the most bottom layer of the stack for any artificial intelligence is sensory data acquisition. By that, we mean audio or microphones are a sensor, where you speak and you're capturing that, so which means your ear is the sensor that picks up the audio. Your visuals is another part of sensory data, and capturing those visuals makes you make certain decisions. But sensory data is not limited to just human sensory data. Now you have things like LiDAR, ultrasonic, LiDAR, especially in, you can imagine self-driving cars is very, very important. And so there are many sensors that machines have that we don't have as humans. And it's absolutely okay to think of these broad sensory data as the underpinnings and the bottommost layer of an AI stack, where you have a good sensory data acquisition layer. Then you can think of that the next thing is phenomena modeling, which is, given that you have these sensory data, you are going to make some decisions. For speech recognition, you're converting speech to text. For image classification, you're taking image and generating some labels like it's a cat or a dog. Or there you're essentially modeling the sensory phenomena. So that's the next layer in this AI stack. Then you start thinking about more decisions you have to make. Let's say you were a financial analyst, given all the structured data of stock trading information, historical data, or credit card data, which shows what people are buying, which companies like if people are purchasing a lot on Target or another IKEA, for instance, or Flipkart or Amazon. So all that you can use to make predictions on what trading decisions you should make, for instance. But there you need to bring in much more context of different kind and make that decision, and which is not just about modeling a phenomena. You are looking for a decision that a human would do for their enterprise, which leads to also a lot of reasoning. And so in that reasoning, you start putting things that are maybe in a different time axis, that what happened in the past, or if I'm making a decision, let's say as a human assistant or a concierge agent in a hotel, you asked for that I want to go and explore this point of interest. Let's say you were in Agra or something and you wanted to look at the Taj Mahal. You want to plan your whole journey for visiting all the different point of interest, eat at certain place. So you're going to do a lot of reasoning, like at this time I'll be here, and at this other time I will be in this other location. And if I need to get food, I need to get it in between these two, because otherwise I'll miss my lunchtime. So these kind of reasoning decisions are extremely hard, and we are still in early stages of this. And lastly, in the AI stack is autonomy, where you're looking at making more decisions without explicit human supervision, which is what we do as humans. As when we are kids, we ask a lot of questions, we explore a lot, and that learning never stops. But the amount of autonomy we gain over time is huge. We don't go and ask our parents for every decision we have to make when we are in our 20s. But from 0 to 20 or 1 to 20, we are doing a lot of asking. And so similarly for the AI stack, when you're doing all these steps, autonomy is the hardest one. And one thing I didn't put here, because there's a lot of debate on, which is artificial general intelligence, because everyone has a very different meaning of what the specific term AGI means. And I'll touch a bit on that. But it is essentially that I didn't put here because it's very hypothetical. But what is definitely true is with these AI techniques, we want it to be more and more generalizable. And by that, we mean that intelligence shouldn't be task specific, that if you're good at one task, you can't learn on a related task. Or if you face a novel situation within your existing task, you should be smart in handling that. And I'll touch on a few of those later in the presentation. So let's talk a bit about our recent AI success. So the one that really caught a lot of attention a few years back was DeepMind's AlphaGo, which was essentially Go as a game, of a board game. And there have been many endeavors of AIs playing chess and other things. But Go was really one of the pinnacles of an AI beating a world champion of Go, in this case, Lee Sedol, was where that caught a lot of attention. Incredibly hard problem, but not as hard as I talk about other things, because in this game once, while it's very easy to say celebrate the success of the AI, it is one of the bounded environments. The objective function is clearly known. You are trying to win a game, and where the game is structured, the state is completely known. You see everything. So you can plan your next move much easily because the objective is known. Again, I'm not taking anything away from that. It's a huge success for AI, but I'm trying to build up to the fact that this is where the AI, it's one of the tasks where AI has a good chance. But let's look at something more where let's look at language, which is super hard to generate. We sometimes, even when we are trying to understand each other, we get confused about what exactly in this conversation, for instance, while it's not yet fully two-way where you're asking me questions, or it's very hard to say that everything I'm saying is being transmitted right, understood right, which means if we were having a dialogue, it will be a lot loose and unstructured. Similarly, so if you were given if you read a lot of text and then a statement or a question was given, and how you respond as an AI is an incredibly hard task. And there's this work from OpenAI, which has generated a lot of attention, which is Generative Pre-trained Transformer and version 3, which has 175 billion parameters. It's again built on the deep learning technology, but it's produced very impressive answers and has been in the latest zeitgeist right now, where where the entire community is very impressed with this work. Great stuff again. But the hardest, in my opinion, and again, this is my unbiased opinion, is the AI, what has been called the AI assistants or AI service, which are capable of many different tasks, which is like the assistants that we talk about. But I think of them as AI experts in each of the areas. That's the way I think about Alexa, for instance. It's an expert that can give you assistance. It can be your trusted advisor. It can be your companion. And Alexa, Siri, Google Assistant, all of these are incredibly hard areas because the goal of the interaction isn't known. When I start asking for what's the weather in a particular city, if it's not my home city, most likely I have some goal that is hidden. And unlike an AlphaGo game where the goal is absolutely known, and what the AI needs to do next based on that initial request is a very hard thing to determine. And I may ask for weather, but then I may end up shopping something or listening to music. So the goal evolves from something very initially, which was very different, to a state that is quite different from where we started. So given this evolution is hard to predict for AI, this is the hardest task. Self-driving cars are also hard, not because though about the complexity of the technology or the sophistication. Definitely on the sensory side of things, it's a marvel, and also in decision making. But from a number of discrete things that have to be handled, it's not that many in terms of the complexity of the problem. But a mistake in self-driving car can be very expensive because you cost lives. That's why it's a very, very hard problem too. But if we look at the tasks that AIs are doing nowadays and in the future, I would put this conversational AI, or what is popularly known as AI assistants, as the number one hardest area for AI. So with this, I would love to dive deeper on these elements of conversational AI. And as you know, I grew up in this late 70s and 80s. So it was where Star Trek was on top of our minds then. A lot of you are very young, so you may not know about Star Trek. But that was where one of the most inspirational thing in Star Trek was this computer you could just interact with voice. And that has been the inspiration for many of these conversational AI systems for a long time, and was thought to be science fiction. And so I'm so feel privileged to be able to work in this area. So it's important to see why conversational AI, right? So if you think about every decade, there is a big shift in how humans interact with machines. In the 70s, again, a lot of you weren't around, we were happy with a character mode where you could just work with a terminal, essentially. In the 80s, you had a graphical user interface, which was a big, big deal. When I got one of these computers, I was like, wow, this is such a big revolution. Then the web came in the 90s, and the internet just revolutionized how we consumed information, how we access services. It was just a transformation of unseen kind. But that even that got disrupted. What we thought was great to be in front of a computer and browse the web to get answers of what we see, or just get entertained in those days as well. Suddenly, with the mobile phones and the smartphones specifically in the 2000s, was a huge revolution. You had a device which was more, nowadays is as powerful or more powerful than a computer that you have at home. And you can do so many tasks on it in the most intuitive fashion in terms of human-machine interaction, where just touch, even a 1-year-old can operate a smartphone, which is a great testimony to the simplicity of it. But if you look at us as humans, we are intelligent. We also interact in a very high bandwidth fashion with what is essentially the most simplest thing we're born with. It's innate, is language, and specifically speech. We speak, we understand each other, and that's really hard because there is no clear structured representation for how to represent knowledge in your brain and how language plays with it. In terms of accessing that information and conveying as between each other. But that was the inspiration, like the human communication that is very efficient using natural language. What if you could speak to a machine from a distance, and essentially just have a conversation? And that is with that, you now have more ambient computing, where there are these distance devices. You just speak to them when you need it. They were there when you need them, and the device always is there, but the AI assistant can recede into the background when you don't need it. So that is what we call VUI, or voice user interface, where just speaking to the assistant becomes a natural paradigm, very much like as we speak to each other. And the fact that you can interact with computing that way to achieve your daily tasks has revolutionized daily convenience. So let's take a look at how that voice user interface or conversational AI has evolved. And this has been a very, very long journey. The company I worked first for was Bold Bananic Newman, BBN. That was like one of the founding sites of the internet as well. And that has been doing research in this area since the 1970s. And those were done by Defense Advanced Research Program agencies. Funding from the US government was funding this research in the 70s the person who hired me was one of the principal investigators for Hear What I Mean system that BBN developed in the 70s. And there were a few things from Carnegie Mellon, from SRI, Stanford Research Institute, where a lot of research was happening. If you look at the top half, from government programs sponsored by the US government, specifically the Defense Advanced Research Program agencies, or DARPA. But it's been a long journey. In the first systems have only a vocabulary of a few hundred words, close to 1,000 words maybe. In the 80s, there was more work on air travel information systems, and the vocabulary increased to thousands. In the 90s was when a lot of advancement happened on commercial applications, as well as government programs, where you could transcribe automatically broadcast quality speech, which is much cleaner, like news transmission, for instance, where there's one news reporter or a news anchor that's speaking all the time. In those days, that was much easier to recognize the audio and convert to text. But then also, in the same time, I worked on a lot of these systems where we were looking at directory assistance, for instance, or where you can call and ask for a number for a business. Let's say you wanted information on Walmart on Main Street in a particular city. You could get that by the directory assistance systems. But then what really took off was another area, which was language translation. You speak in one language and that gets translated into another, or broadcast news in languages you don't know, let's say Spanish, French, Arabic, and that being converted into text was a big impetus for the DARPA programs. One I myself worked on was translators that you can take to a different part of the world. Where the US government was very interested in talking to folks on the ground in Afghanistan, Iraq, which were war zones, but for more humanitarian purposes, where you could speak in one language, and we put this technology on phones where you can speak in one language, translate another, the other person can speak in the other language, and back. And that is like, again, the universal, a lot of people think of the universal translator, but that's still far away. But it's gotten quite good. We just launched language translation on Alexa as well. But in the 2010s, from offshoot of the KALO program from DARPA in the 2000s, mid to late 2000s, is where Siri came out, essentially from SRI. And then Google Now and Cortana from Microsoft follow. But in this one, the key thing was that these were assistants which were on your phone. However, what the idea Amazon had was, what if you could just build a device that you can speak to in home without using your hands and eyes? So you just speak and you don't even have to look at the device, and the device gives you an answer. That was what became Echo, and Alexa was launched in 2014. And I joined before the launch in 2013 in Amazon. So it's been a very long journey, as you can see, on where how long it has taken us from getting from this in the very earnest research in 1970s to 2020 now. So 50 years has gone by to get to this stage. And I think we have another 50 years in front of us before we'll think we have gone too far on this area. So I always feel we are still quite behind on what we can do with AI like these, especially the AI assistants or the personal assistants. And what has happened, like if you look at the technology, because this is all about conversations where input is speech. In the 1980 to 2000, there was, I think there's somebody's unmuted. So in the 80s, there was a lot of
Please
work
mute everybody.
In what was called hidden Markov models, which is one type of technology that was used for speech recognition. But then we got into a lot of the era of deep learning, essentially, which was 2010 to now. And the field is still building on deep learning, which is giving a lot of improvements that we couldn't think of in previous terms. And this just brings that together. So if you look at what made conversational AI, and when we launched in 2014, Alexa, no one thought this distant speech recognition or talking to a device was possible. Even DARPA did not think that was feasible. But three things made it happen for us. One was machine learning was becoming big, and we were having deep learning specifically. While it was still early and nobody knew how to do it right at scale, we felt it's time to double down, and we got a lot of large-scale deep learning happening on millions and millions of hours of audio data going. The other fact was that there was an abundance of data that didn't exist previously. And lastly, with AWS's compute power, we had near infinite computation power. So all three came together for us to reduce the barrier to entry into the AIs like Alexa. And that was super important, and nobody had done far field speech recognition or distant speech recognition. So we had incredible hard challenges to solve, but because of the combination of deep learning with computation power and data, we were able to achieve that. So in 2014, when we introduced Alexa, Alexa only had these 13 domain/skills, if you may. They were not, but they were quite potent. Like you could ask for a music, which is a very, very hard problem because there are lots of artists, millions of songs. And if you look at when I talked about machine-like efficiency and human-like intelligence, if I asked you to play songs by Mohammed Rafi, it will still take you, a human, a lot of time to get that going, right? And if I change the artist, a human will still have to go look up, play. And even if you think about in your app, you'll have to search for it unless you had a shortcut or a playlist. It's very inefficient for humans to do any kind of search and lookups. Whereas for machine, if you just said play songs by Mohammed Rafi, that was instantaneous. Within a second, we could play a song, and it was delightful. When it started, that made us get really excited that this technology, especially the fact that you don't have to open your phone, ask it something to do, you can eliminate 3 clicks, was very powerful. The other thing was, if your phone looks anything like mine on the smartphone, you have so many apps. To get to any place, it takes at least 3 clicks or 3 swipes. Whereas here, you don't see any of that clutter. You just speak, and Alexa gives you an answer or does a command, takes an action based on your command, or have even a conversation with you to get you what you need. So 13 skills were there in those days in 2014. We were the only ones developing on it. 1 device, 1 language, which was US English. But that has evolved a lot over time. But for that evolution to happen, let me just take a step back and say how Alexa works, right? In 2014, how it worked was you had, the most important thing was when you speak Alexa, it should wake up. And when you're not speaking, when you don't say Alexa, it shouldn't wake up and start streaming to the cloud. So the wake word detection happens only on device, only when the wake word is heard with high confidence that the device starts streaming the audio into the cloud. And then in the cloud, we were converting speech to text. And then the text is interpreted, the speech to text part is called automatic speech recognition, as you can see in the slide. And then the next part is, okay, if you understood the text in terms of you recognize the text, you still have to understand it. That is done by the natural understanding component that takes the text and converts into a meaning form in terms of meaning representation. And in those days, it was what's the user's intent and what are the other salient attributes that we need to know so that we can make an answer or take an action. So if you said, Alexa, play music by Mohammed Rafi, or just play Mohammed Rafi, you have to parse it that it's a play music intent by an artist type, which is Mohammed Rafi, In this case, I'm clearly dating about my music taste right now. And then once you've understood what the customer wants or what the user wants, you take an action. But before you take the action, you have to convey the action. So you would say playing this particular song, which is converting the text response into speech so that Alexa can speak it back to you. So this was, in a simplistic way, what were the operations behind making the conversational AI of Alexa work. And each of these represented a very, very hard challenge. Wake word detection, as in detecting the wake word name Alexa, is very hard because in a normal home, you're having a ton of conversations. And just to listen to that wake word with high confidence and be ready when it's spoken in very low latency was very hard because most of the time you're not talking to Alexa. So this had to be very, very accurate even in those days. And we had to work very hard. And in fact, we put a deep learning model and a system on the device, which is really very low resources. So low resource computation was happening even in those days in 2014, which was a deep learning based wake word model with a very large parameter set. Then same on speech recognition, the cloud was also a deep learning based system, but it had many more words to recognize, millions of words to recognize, because artist catalogs are big. Even in those days, weather information in different cities was also big. So even though those were like 13 discrete things Alexa did very well, the span of those and the vocabulary required was massive. We also had question answering, and people could ask any question like, when was Abraham Lincoln born, or where is the Eiffel Tower, or how tall is Mount Everest? So we were used to get those kind of questions too, which means the vocabulary is really unbounded. Then the natural language understanding part was also very hard because you had these massive big domains and you had to figure out what's the customer's intent with high accuracy. So instead of, in those days, the state of the art used to be, or state of the art systems still used a lot of rules. Instead, ours was a more statistical probabilistic system to determine what is the best intent given this utterance and how to fulfill it. And then text to speech, of course, we had to be very natural, not have a robotic voice, otherwise customers won't adopt Alexa. So going forward, where we are today. So today we have more than 100,000 plus skills. These are skills built by both developers and that are internal to Amazon and external developers. People in India are making skills. In fact, a lot in the education domain has been phenomenal to see what people have been doing. Like there's an Amar Chitrakatha skill, for instance, and so you can, I mean, as a kid I used to read that. So so this is very fulfilling that we have essentially democratized AI. The barrier to interact and build with AI has gone down. We have over 140,000 different device types that integrate Alexa, not just ours, but even third-party devices. Alexa is in cars and other speakers, even a toothbrush and hairbrushes we are seeing Alexa being put into. So it's fascinating to see that this is another kind of democratization where any device manufacturer or any application developer can integrate Alexa and build a skill that is custom to them. Let's say you're a hotel company and you wanted Alexa in your hotel rooms. You can do that by either buying Alexa device or another device you can put which is integrated with Alexa, and then write a skill that lets you get information, let the hotel guests get the information and interact with it. And as I mentioned about the democratization, that skills are being developed by developers who are not necessarily AI experts. You require very limited coding expertise. In fact, in many ways, you can even write skills without knowing any code. In fact, Alexa users themselves can take advantage of a capability called blueprints, where they can build their own skills without writing code. And that is, I think, something that was unthinkable and has been a big paradigm change. If you ask me in 2010, even that Rohit can conversational AI be democratized this way, My answer would be, I don't think so. And so this has been, as proud as I am with the far field speech recognition or distant interaction with ambient devices and large scale natural language understanding for you to speak to a device, I'm equally proud of this democratization because it has made everyone participate in this AI revolution. And school students, people in underprivileged communities are able to take advantage of this. So that is very heartwarming for me to see, especially in India. That is where I'm getting a lot of this such excitement around Alexa Skills Kit is that makes me really, really, it's humbling and makes me feel very proud that this work is actually making a difference. So, but when we launched in 2014, we made a promise to our customers that Alexa will get better as you use it. And we have been true to that promise. And that's because we think of 5 AI pillars that make Alexa smarter and better for customers. And if while it seems very Alexa specific or conversational AI specific, if you think about it, it's not. These pillars, and I'll talk to each of them, are self-learning, as in the AI should have the capability to learn much faster on its own. Natural, as you can imagine, the beauty of Alexa was that it was very natural. My mom, who doesn't use any computing, doesn't even use a smartphone, now she is, but she wouldn't, but she used Alexa before the smartphone. She could, even in her limited English, she could speak to Alexa and Alexa understood her basic commands. And so that is the hallmark of a technology like that. So natural is definitely a pillar. While we are incredibly proud of where we were in 2014, but this is an area where we have many ideas, and I'll talk about what some of the work we are doing. Knowledge is part of where competence. Alexa needs to know a lot. Like, it needs to have encyclopedic knowledge so that it knows about the world, knows about the services in the world, like if you're looking for a plumber in the area or an electrician, even that is local knowledge. And also personal knowledge, like Alexa should know about me, my preferences, and so forth. So knowledgeable is another pillar. Context aware, this is where, given the context, Alexa needs to make a different decision. If I say, play Hunger Games, and Hunger Games is a book and a movie, in the context of if my TV is on, it should turn the movie on, not the audiobook, or without asking me a question every time. Do you want to listen to the book or the movie? Watch the movie, right? So that's where context awareness comes in, and many different kind of context that is not limited to natural language that I can speak about, because this is ultimately AI. It's a voice forward AI or a conversational decisions it makes are not limited to just voice, and I'll discuss that later. And lastly, Alexa, when we launched in 2014, was very much like you speak a turn and Alexa takes an action or responds to your command, or gives you an answer if you asked a knowledge-related query. But that's not how we interact with each other. Often we have an ill-formed goal in our mind, and we are refining that as part of the discussion between two intelligent humans. And people's expectation with Alexa is rising in the similar way that, can Alexa help me with many different things? And one way to do that is for Alexa to become very conversational, and I'll discuss that too. So let's start with first the more self-learning part. So if you look at it, I talked about Alexa's skill is like there's a hockey stick effect where skills have grown from 13 in 2014 to 100,000 plus. At the same time, Alexa, so we think about accuracy in terms of 1 minus or 100 minus error rate if you're computing in percentages. Error rates have gone down on everything Alexa does. And this is very hard to achieve as the complexity of request has increased. How do you make it such that you have to invent a lot on your algorithms, make your models much better such that error rate continues to decrease? Because if you kept increasing skills and errors become higher, then customers will be disappointed, and we didn't want that to happen. So the way we remember, I said in 2014, we everything, even when deep learning was still new, we adopted deep learning very early, and that did help. But now we have done a lot of work in going from deep learning that was usually used a lot of supervised learning, which means you would had to give a lot of labeled data, millions of utterances that were labeled with what action Alexa needs to take, but that doesn't scale. So very much like humans, we have been moving in what is now popularly known as self-supervised learning
Hello, sir.
or unsupervised learning. And along the way, we have made such that Alexa's reliance on supervised learning, which is some human giving you answers, to Alexa learning more on her own or its own, is what we have been working on. And there are 4 techniques which I'll touch upon very quickly. One is active learning, where when you're given ground truth in terms of labeled data, you build a model, and if you think about the model, it's separating the right answer from the wrong. Or let's say you have a 2-class problem, you see the orange one and the green one. The model is good at separating these two, but there's a lot of stuff in this gray area in that span. So if you wanted to minimize amount of labeling you do, because it's too slow to get labels from humans, then you would say, and expensive, but leave that out first. It's really that we wanted Alexa to get faster, get smarter faster. And for that, the very first thing we injected in Alexa's learning was active learning, where Alexa tells you about these gray areas where it's unsure about the answer and says, you know what, I don't need answers which I'm able to separate very well. I need human labels for areas which I'm unable to separate that well, which cut our data needs by 100x. And that was extremely powerful. And marrying that with deep learning made deep learning get better faster for Alexa's technologies. Then the next one, which is very proud of this work, because some of this I did in early 2000s and late 90s, was where you tend to have small amount of labeled data, which is in the greenish block, and a lot of unlabeled data. So this we did with deep learning, though nobody had used in speech recognition area with all success a large quantity of unlabeled data in actual production setting. So what we did, we came up with an approach where you have the labeled data train a teacher model, which is high quality. And then a lot of unlabeled data is used by the student model, where the teacher is providing some of the supervision. And this is called semi-supervised training, because there's no human involved here, other than in the original labeled data, which was much smaller, that gave you answers to train the system on. And this has been a massive improvement, where this, imagine you deploy, we have, we have Alexa in Hindi now, but it was one of the languages we launched about two years back. Hindi, again, it's a challenging language because, and even Indian English is challenging because you have a lot of mixed language content in there. So we deployed the semi-supervised recognition. Imagine if you deploy that, then as the customers are using the system, this system will get better. The speech recognition will get better with this approach without any human providing answers on this new data for the model to be trained and updated. So immensely powerful. And this has been, for the last 2 years, a lot of improvements in our production systems have come from this technology. So another one, in terms of learning, this we do very well as humans, that we transfer learning from one task. Let's say we knew about weather, restaurant, food ordering, and so forth. Then we can learn a lot about recipes quite well. So we have done the similar work in neural networks, where we can take a pre-trained model on many of these different domains and learn faster on a new domain. And this is, again, has reduced data needs, but more importantly, made Alexa smarter faster. If you look at, but this one is another one where all these techniques I talked about still take, even though there's no human involved in making the system better, the learning happens at a global level across the population group. And the model does get updated, but not as quickly as, imagine if I said, Alexa, when my kids were young, play the ABC song. Alexa has no idea what ABC song is, so it would fail. Then I would say, no, Alexa, play the alphabet song, and that worked. So now the question is, well, that worked. So Alexa can understand now that when I say play ABC song, then I really mean the alphabet song. So the next time, it doesn't need to fail. Instead, when I say play ABC song, she will play the alphabet song. And well, if I am the only user, if it encountered that problem, then I'm unlikely to say play ABC song again because Alexa failed at it. So I would say play the alphabet song. But the beauty is there are other people who have used this, have made the same error patterns, and they are able to help Alexa learn, so that a new user, let's say someone else in my family came and said, play ABC song, because he or she did not have an idea that I have tried that and it failed, this will work. So this is a self-learning approach, which is hugely powerful from that perspective. So let me show you another one.
Alexa, set the thermostat to Rohit's vacation mode.
What do you mean by Rohit's vacation mode?
60 degrees.
The heat's set to 60. I will remember Rohit's vacation mode means 60 degrees.
Alexa, set the light to Rohit's reading mode.
What do you mean by Rohit's reading mode?
40% brightness.
Okay, I'll remember that Rohit's reading mode means 40% brightness.
Now, just to show that she has actually learned what reading mode is, let me first turn the lights off. Alexa, turn off the light.
Okay.
Alexa, set the light to Rohit's reading mode.
Okay.
So this is what I call interactive learning. This is the next step of where, rather than in the first example I gave, where ABC song and alphabet song, Alexa was able to learn that correlation automatically, that it's really the same concept being asked with a different vocabulary. Here, reading mode, vacation mode, Alexa has no knowledge what those concepts are, but it is able to use, just like us as humans, when we don't have an understanding of a concept, we ask a question. We ask, as if this was like, if somebody came and told me, imagine if I was a human asked to change the thermostat to vacation mode, I'll say, what do you mean by vacation mode? Alexa did the same thing, asked you there right away, what do you mean by vacation mode? This is live now, just launched earlier this month. And what this does is got the same kind of capabilities as a human would by first localizing which part of the spoken request Alexa doesn't understand. And then it once it figures out that this vacation mode or reading mode is something that Alexa didn't know, it goes into a dialogue to acquire this concept. And here I said a particular settings, but my son can come and say a different setting, reading mode could be 80% brightness for him and 90% brightness for me. And so these kind of actions, which are very, now Alexa can learn new concepts through these teaching sessions. Very early still, but this is putting us on the trajectory of more generalized AI, where like the human aspect of generalization, we learn new concepts through self-supervision, and this is going in that direction. Let me keep going. So that was self-learning. Next, let's look at natural. By natural, there are many things Alexa can do. You can, earlier, a very simple, useful thing, but was very hard. If you were trying to populate a grocery list that, when my wife says, like, we need XYZ, nowadays we've moved completely to online groceries. But when she used to, like, so it's when we would put a grocery list or a shopping list in our Alexa app through voice, if you said, Alexa, add strawberries, blueberries, bananas, then it will add it like that one single thing you see on the screen here. Whereas if you nowadays, if you say these different items in one shot, it parses them into a separate list. So you can take a multiple step request in one shot, and that is the hallmark of naturalness that we strive for. Let's look at another one where you say, add strawberries, peanut butter, and jelly to my shopping list. This is again just showing how this one particular works. But let's go to since we're running a bit short on time, look at multiple commands. You can say play a song and turn on or off the bedroom lights. So then you have to parse it and into two requests. And look, you can't do this with just rules, because the song name or the artist name has the word "and" in it, and an "and" between the two commands. So you just can't write a rule saying if you see "and," it's really two commands. No, you need to use understanding to break this complex request into two simpler requests that can be done independently. And that again, we use deep learning based approaches. Another natural one, which is very much we do quite often, you would ask, what's the weather in Delhi, or what's the weather? And then your next request is, how about tomorrow? And in the second request, you're not saying that it was really related to the previous request. You're not saying, how's the weather in Delhi tomorrow? So if think about it as a machine, you just got the second request. There's what about tomorrow, which is very ambiguous. So now you have to maintain the context from previous turns and answer this request. This again, through combination of deep learning and entity extraction, we are able to figure out the missing part here is the city, and the request was the weather, and then merge those two, take the context from before and merge it to give the answer of the weather in Delhi tomorrow. So that's the way you need to think about how we, as well as humans, take previous context and apply it on the current request. Same thing Alexa does to make it be very natural. I mentioned we have 100,000 skills, right? And so customers can't remember all these skills. So how do you get Alexa to not be unnatural for interacting with these skills? Because if you have to say, Alexa, ask Uber or ask Ola to get me a car, you have to remember that there's an Uber capability or an Uber skill or an Ola skill. Instead, you want to do this as naturally as possible. And then, so we built that system too, that where now for most popular skills, you do not need to say the skill name every time or remember that, because Alexa does that thinking for you. The way it does it is when you say, Alexa, get me a car, it figures out that most likely this is whether you're looking to get a car as a ride sharing or well, we don't sell cars on Amazon, at least yet. So it's not like you're trying to buy a real car, but you could be looking for a toy car. So you still have shortlisted this, right? And then shortlisted to a few skills. And then you apply a lot of context given, okay, does the customer have an Uber account linked or an Ola account? And then you can actually use a lot of that context to say, okay, I definitely think this is by ranking and using the scores from these different skills to say, I think I'm pretty sure I should give the customer the answer that, okay, I'm getting you an Uber to go to the airport, for instance, right? So those were the naturalness on more of the understanding side. I don't want to lose the fact that how Alexa sounds and how natural it is in responses, how does she use prosody and how her intonation is and how she speaks back is as natural as possible. From that perspective, this was a huge advancement where we also applied deep neural networks to actually make text-to-speech synthesis, as in producing sound from text, be as natural and human-like as possible. And this technology has been super important for making Alexa read a lot of long-form text and speak it out. As in, imagine if you're reading a book, it gets quite jarring if the prosodic patterns aren't good. Because when humans read, they apply a lot of context of the words and other elements to put emphasis on, which words and so forth to stress. The same thing Alexa is able to do with this technology. And this has made Alexa's voice more and more natural as we've gone. And what has also done is we have now celebrity voices on Alexa. Samuel L. Jackson is one celebrity that is available on Alexa. And we also have a wake word for it. So you can say, Sam, ask for the weather. Sam, what's the weather today? Samuel L. Jackson's voice comes back with an answer. So that's quite fun. And in India, we are working with Amitabh Bachchan to be one of the celebrity voices in India. So he's my childhood. I'm a big fan from early days, and so excited that will happen in next year. And we're already working with him to bring that kind of a voice to Alexa. Moving to the more knowledgeable. So this is where what we do is we have to have a massive knowledge graph of entities in the world and their attributes and how they link with each other. So we have a knowledge graph now that has grown in huge bounds with millions of entities and billions of relations in there. That's how big we have become in terms of being able to give answers. And you'll be surprised what type of questions customers ask an Alexa. So for instance, people can even ask, how far away was Mars when Obama's wife was born? Like, this is a very complex question, but the knowledge graph and the underlying natural language understanding elements are able to parse these through the information that's in the knowledge graph to give the answer. Like in this case, the answer would be which will be like a bunch of things like on January 17, 1964, which is the day Michelle Obama was born. You look here, it doesn't say who's Obama's wife, right? So you have to look that up. So there's many steps that happen. And then you say Mars was X million miles away from Earth. Like I don't know why, but people do want to stress these systems, and these kind of questions are being asked to Alexa. As you're looking at knowledge graphs and you're giving information, it's very important to give on multimodal devices, like we have Alexa devices with screens now. So it becomes very important on how you present the information, because you do have your eyes and you want to look at the responses. So the knowledge graph then essentially is not just a discrete set of elements which are all language or text. It needs to have great visuals, multimodal content, and then we have to put it on the screen in the best form. There's also a lot of AI involved in doing this kind of retrieval and knowledge graph population. And the presentation, of course, requires such that the rendering is very good on our screens. But the real science behind it is on the multimodal information retrieval and knowledge graph acquisition. Moving to context aware, I touched on this a bit. But let me give you a few examples that go beyond natural language. So if I come home late at night, let's say from work or some other thing, and my wife is sleeping, I want to set an alarm for tomorrow. I don't want Alexa to wake her up if I say, Alexa, set an alarm for 7 a.m. So I could whisper to Alexa. And if I whisper to Alexa, Alexa whispers back and with a very short okay, or set the alarm for 7 a.m. so that my wife doesn't wake up because of me and Alexa. So from that perspective, the ability to detect that someone is whispering and then adapt your response based on that is context awareness of one form. Other one, which is very, very useful, is like Alexa now has hunches. Very much like humans. This is where Alexa can say, you know what, I think it's 11 p.m., lights open. So especially, I mean, it has to be connected. So it can come back and tell you that looks like you're headed to sleep or it's late in the night, but your garage light is left on. Or a lock is left open, or a coffee machine is on. So these are very useful in the moment. Which is what we call hunches, very much like the instinct we as humans have when something is amiss. Similarly, we also have this functionality called Alexa Guard, where if you say Alexa on guard or go to guard mode, or Alexa, I'm going away, So your home is empty, then Alexa goes in this mode where it's listening for events that tell you that something could be going wrong. Like if Alexa hears a glass breaking noise because someone broke into through your window, or a smoke alarm going off, which is very common in the States here, is where Alexa will notify you on your app that I think something is amiss in your home, and this is the Alexa Guard functionality. Moving on to the last pillar, which is perhaps getting most important now because of what customers' expectation is with Alexa, which is always rising, is customers have very latent goals. When I say, Alexa, what movies are playing nearby, I'm not looking for just information on movies or what are the latest movies. I may be planning a night out with my friends or family, which means I want some place to eat. I want a way to get to the theater and so forth. So I showed this last year, and now we have this launched of the capability of where Alexa can build more conversational skills where developers can build more conversational skills by writing very little code, because these are very complex. Think about even ticket purchasing for either a concert or a movie. You need to know the movie time, the number of people who's going to be involved, which particular movie, right? All these information can come in many different orders. So previously, if you were a developer, you would enumerate all these different states Alexa needs to go through, or your skill in this particular case. Whereas now you just say, here's my API, and here's the set of information I need and a few example utterances. And you don't write any code on what steps Alexa needs to take to fulfill the goal that the customer has for these skills within your skill. Similarly, so the way this is happening, again, as I mentioned, is you provide a little bit of information without writing code, API references, what key entity types you need to care about, like movie names, hours, as in time, detail, and then a dialogue simulator generates a lot of different ways customer may ask for things, and a deep learning based model is trained using the simulator's output, and during runtime, all this information is used to predict what's the next best thing your skills should do or Alexa should do based on this deep learning based models. So how we behave as when we get a request, we ask a question for what to do next. Alexa does the same if it needs to fulfill, if it needs more information from the user, like what time do you want to go for the movie? But eventually it's able to fulfill that goal without following the same structure or pushing for the same structure. So you can speak more naturally to Alexa and it converses with you at your speed and your pace. Which brings me to the one that is really groundbreaking here when I mentioned about speaking at your own pace is that when you speak to Alexa today, you have to use the wake word on every utterance, every turn. You have to say Alexa, but that's not how we speak. If I was having a question with Surinder sir, then I would not. I wouldn't say his name on every utterance, nor would he say to me on every utterance. He will look at me, or based on that, if there were multiple people involved. So Alexa is able to do the same thing. Let me, instead of going through how it does it, let me just show you, because we're running over time a bit.
I'm getting hungry. How do you feel about ordering pizza tonight?
I could definitely go for some pizza.
Awesome. Alexa, join our conversation.
Okay, let's talk.
I want to order a thin crust specialty pizza from Mike's Pizza.
Today, Mike's Pizza has the following specialty pizzas: 3 cheese delight, meat lover, supreme, I have a large, thin crust.
Decide what to do there. So incredibly hard problem, and this will we have a prototype in lab working, and in 2021 I want to bring this to customers. And as you saw, it is the way they invoked Alexa in this mode was Alexa joined the conversation. So it's very much where Alexa becomes your family member in this interaction, and that is the way, the ultimate natural and conversational that an AI can be. So I'm looking forward for the team to get this done. We very proud of them getting this prototype built, but I think it will take a good amount of next year for us to get this right and launch to our customers. So I wanted to end with the note of how where all this is headed, right? So if you 2025, not that far, the number of connected devices in the world will just keep growing. If you look at some predictions, it can be anywhere between 75 billion to 100 billion devices that are connected. At that point, you have an incredibly challenging problem of cognitive load on how much we have to spend as humans thinking about how to interact with devices and services is just gonna blow in many different ways. Technology has been great, but it has also increased the amount of thinking we have to do. And with Alexa, our mission is to shift that burden of thinking on where we shouldn't be thinking much about, and using these services or these devices capabilities as naturally as possible, using voice or visuals or other sensors, and Alexa also becoming more proactive and giving you more help the way I showed you in hunches and so forth. This is the world that we have to be prepared for. And as we think about this, even in countries like India, where infrastructure has usually lagged, but with the explosion of 5G and other connectivity that is getting better and better every day, even countries like India will have this challenge where our customers and users will want to achieve more with less thinking about stuff that shouldn't matter. You should be thinking about more creation, more learning as humans, rather than just figuring out how do I get this particular service done or how do I switch on my lights. You want to spend more time thinking about things that will advance your career, your futures. And so I'm looking forward to this world. And I also feel like we have a lot of work to do, especially in India, to make it be so affordable, so accessible, so portable, and so responsive that Alexa is just with you every time, to ready to help, independent of who you are, how much you make as in terms of money, or on what your background is. So I really want Alexa to work for everyone. And that will require many different things coming, like you can think of people with disabilities have had shown huge adoption of Alexa. Makes my heart feel, I mean, it's very heartwarming and very humbling at the same time when I hear stories of how somebody's life got saved by a customer dropping in on their mom, and because they didn't hear from her and she was on the floor, and they then called emergency services and her life was saved. And also at that point, you have to start thinking about fairness, like Alexa should work equally well for everyone. And Alexa needs to have a lot of empathy and be personable for people from all different echelons, different groups. Very, very hard problem, but as a scientist, this is what I'm after. And lastly, I want to leave with the thought that with Alexa, we are on a quest towards a more generalized intelligence, but it's still day one as I think about where we can go. So thank you so much for your time and listening to me.
Thank you, Rohit. Thanks a lot for a wonderful presentation.
Yeah, thank you. So I think, Rohit, we have given you the questions. If you want to pick them up, you can take them one by one from the Google Doc.
Or you want me to read it out?
No, I can. Should I go one by one, or from the order that?
Yeah. Maybe you can go top down and pick up one by one.
Okay. The first question I'll read out is: what do you think is a more difficult problem to solve? Is it vision or language? And this is from Ankur, a UG undergrad student from graduating in 2021, I assume. So thank you, Ankur. This is a very good question. I think the way you've posed the question is whether I would go back slightly, because I think it's the combination which is the hardest, right? I mean, because as I mentioned in my last slide, that we are looking for more generalized intelligence. That starts with many multi-sensory capabilities, audio, video, all of it. From just the fact that what you do with audio and what you do with visuals can be very different. So I think both are equally hard at this stage, and the combination of, as I showed in the natural turn-taking demo, where you have to fuse these sensors, makes it both a bit easier and harder at the same time, right? Because you have, in that particular example, the visual cues were helping what decision you make. But if you asked for, if you went back and go to the core levels of intelligence and you said, is language understanding harder than visual understanding? I think it depends on the task. Language understanding is very, very hard in the context of virtual assistants like Alexa. And visual understanding, if you were trying to imagine a scene where a robot is describing you the scene in natural language by understanding the scene, that's very hard problem. Whereas if you're just doing, people often think visual understanding is just image classification, whether it's a cat, dog, or which activity is in this video, then you would say that's a slightly simpler problem. So I think it becomes specific to the task. But if you're asking in context of AI vision that I showed in terms of human-machine interaction, interactive systems, that is like Alexa, then both are equally hard. But the advantage we have is that fusion of cameras and mics and the sensory processing from there gives us hope that we can actually solve that problem that I showed you in this demonstration, which I want to build on the natural turn taking. Okay. Should I go to the next question?
Yeah.
So there was a question on, I'm just looking at what was the reason for AI winter and how it ended. Yeah, this is a very good question. The AI winter was again, I have to get my timing right. This was where what is referred to as when a lot of the neural network technology, there was a lot of skepticism and people had given up on those approaches. And then I would say in the 2010-ish timeframe, I have to get my timeline right here, with the emergence of deep learning and especially deep neural networks became a big deal, and then started moving into a lot of tasks being happening that people who used to work on speech recognition had given up on neural networks and deep neural networks. And then in 2010 timeframe and later is when it came back with a bang. And I remember in 2013, one of the conferences, Jeff Hinton, who gets a lot of credit for bringing deep neural networks back, was describing his journey with that. So it is quite satisfying to see. There's a very good lesson here to not give up on approaches. There's sometimes timing is not right. So if you felt you had a great approach to a problem you were solving, my advice is to not give up. And there will be summers and winters. The neural winter or the AI winter was definitely happen. But at the same time, the field has really gone in the right direction of, if you think about, there was first very rule-based AI, then machine learning became big, and neural networks as in deep learning became big. But now there is a neural symbolic AI that is a combination of some logic from before with machine learning and specifically deep learning that's coming back. So that's another example of why these winters and summers will happen. That's just like life. And it's important that if you have a good idea, I believe no good idea goes waste, and it comes back in one form or the other.
Okay, just a time check. We are at 11:26. I don't know. We want to make sure that you're good with extending, or if you want to end that, we can end at 11:30 as we planned.
Hard stop in 5 minutes. So let me
go
through the that
please.
I think are more unique that you can't, and more unique to the university and India specifically.
Okay.
So see this question on how are Indian startup or existing companies contributing to the VUI sphere, voice user interface. This is a very good question. So, and then there's a question on India's languages. So first, Indian startups there are many startups that, as I mentioned, with the two APIs that we have built on Alexa Skills Kit and Alexa Voice Service. One, Alexa Voice Service lets you integrate Alexa in anything you want, like your app or a device. And then skills you make for, if you wanted Alexa to learn something about your company or your customers and build an experience that you do with Alexa Skills Kit. And those are two ways Indian startups and existing companies are already contributing. I would also say with a lot of AWS's AI technologies, so your question was specific to the voice user interface, but I want to broaden it to AI. The barrier to entry into AI has become much lower. So you don't need a lot of infrastructure because there's computing in the cloud. All these services are abstracted at the right level where you can actually now build something quite quickly. So I wanted to make sure that there's a lot of excitement around that, both in Amazon and other companies, especially about India. The other part you mentioned, the challenge is also the challenge here in India is the variety of languages, again, going back to Alexa or voice user interface. How to overcome this challenge? You're absolutely right. Even as I mentioned, English, because there's mix of so many language and types of words that are specific to a region, they think people name, city names, that India is the hardest language problem that I've seen. We currently have Alexa in two languages, Indian English and Hindi. We constantly look at how to expand it more. And the way to overcome this challenge is where we are working on a lot of multilingual language understanding and speech recognition capabilities, where using technology like deep neural networks, specifically large pre-training, you can train it on a mix of languages, and then your barrier to recognizing in a new language goes down because you can leverage a lot of data from others. So this is both, we have done a lot of work in both transfer learning and multilingual learning that is going to pay off shortly. I can't give you a roadmap for the languages, but this is something that we always worry about. I'm just going through the span of topics. Somebody mentioned, there are two questions that I mentioned that I'm going to summarize quickly. One is privacy. Many of my friends are concerned about privacy when using devices like Alexa. My point is, just to clarify here, is privacy is absolutely paramount. We believe in transparency and giving the controls in the hand of the customers, again, speaking on behalf of Alexa and Amazon in this case, because you asked what can tech companies do to address those concerns. In my mind, if you have the tenets, you have to think about, we are also customers of Amazon and Alexa, even though we are employees. I think of it that way. I have 17 Alexa devices in my home, and maybe more now, close to 20, I would say. And they're always on. Because it's very transparent on when Alexa is listening. Plus, we've given so many control in the hands of the customers that they can now say by voice that delete my audio or delete what you heard today. So we're making it much more easier for customers to understand how their privacy is being kept, because it's a fundamental right, how it's being kept intact. And we have to do a better job of explaining these two as tech companies. And also, as I mentioned, a lot of learning I described where customers can teach Alexa rather than some human listening to the audio and transcribing and giving answers. That used to happen on very, very small fraction of the data. And even there, we have a functionality. You can opt out of any human review so that you don't have, if you have concerns on that dimension too. So again, this is very paramount for AIs. And the second part you mentioned, another student mentioned on Ankur, one was Sharat, the first question on privacy, was the ethics and security issue. Here again, I'm investing myself a lot of my personal time in these two areas of security and ethics. They are very challenging, as you can imagine, on the security side, because by nature, people are it's adversarial in nature. People are trying to break your systems. So we believe in having more proactive detection of any attacks, for instance, right? And also this goes down to how models are being trained. Like we work a lot on differentially private learning, incremental learning, and so forth, which is sort of straddling between privacy and security. And lastly, ethics. I think that is an area where ethics will just keep getting more and more important. No one knows all the answers, but we are very much that if you put your customers first and look at their interests, and we have tenets around this, is that you make best decisions. So this is, I mean, I wouldn't say that the entire AI community has figured out everything about ethics, but if you think from a customer perspective and not so much from technology perspective, then you make the right decisions. Shall we take one last question?
Yeah, please go ahead.
Let me see. There's a question, and since the Abhishek from 2021 class, since the Moore's law may be just reaching to its limit, will it impact on achieving the autonomous layer of the AI stack in the future? A very good question, actually. So whether, I mean, there's a lot of debate of whether what limit is, and luckily we are still taking a lot of advantage on the chip side of things. And as I mentioned about neural network accelerators that make inference much faster, even on the edge. So there's a lot of still, I would say, optimism on the computing side of things. But I want us to think, and this is where I'm working with my teams on, while deep learning has been great, it is massively expensive to train. So if you think about the GPT-3 model, that has 175 billion parameters. It must have cost millions to train, as in dollars, I mean. So and it's not so much the dollar amount that worries me, but it is the amount of energy, amount of computing, that is how it affects the climate. So you have to think about sustainability in that dimension. And I'm big on trying to make AIs be more sustainable in how they learn. With very much like humans operate on very low wattage, like some would argue with 40 watts. And machines are like few orders higher on any learning right now. So as we get, the way I can impact this and the community in the AI community is, while it's great to have this computing power, we need to be looking at methods that make learning more efficient, so that you don't need millions of samples of data. Humans are good at learning with one shot, or think about how many hours of driving you have to do to learn driving versus how many hours of driving a self-driving car needs to learn before it knows how to drive. So there are a lot of these things where I think we can build capabilities on learning side, which makes learning more efficient, which will essentially reduce the dependency on just everything becoming more powerful in terms of computing. That has worked to our advantage, but we have to be thinking forward ahead for the AI stack, especially on the autonomy layer that you talked about. To be able to learn in this autonomous fashion, you can't assume you'll have the same kind of computing, especially if a lot of learning was happening on device or on the edge, where maybe you don't even have the network connectivity to go to the cloud. Okay. Thank you. This was awesome. And if you guys have any questions, I'm happy to answer from that aspect as well later as well.
Thank you, Rohit, for many thanks for the amazing presentation on science, current state, and evolution of machine learning and deep learning and AI successes like the voice user interface, conversational AI and AI assistant, language translation, democratization of Alexa, and many pillars of like self-learning, interactive learning, and so on. It's all amazing. And the evolution of AI successes that Alexa has brought to us in a very natural and human way. Thank you so much. Really appreciate for your time. Appreciate. Thank you again, once again. Many thanks. God bless you with continued success.
Thank you, sir. Thank you.
Thank you very much, Rohit.
Thank you.
Thank you, everyone.
Thank you, Rohit. Thanks a lot.
Nice meeting you, Rohit. Thank you.
Bye-bye.